at this point, our technology allows us to see planets that are about the size of Jupiter. Maybe a little smaller, the size of Neptune, maybe even much larger than Jupiter. And most of these planets we see only not through actually being able to detect them as individual planets, though we have done that now. Most of the time we see their effects on other stars, on the star that they're rotating around. So if you take a very large planet, or let's just take the Earth and the Moon. As the Moon rotates around the Earth isn't perfectly stationary and the Moon's going around it. Instead, they're kind of going around each other. So the Earth is moving a little bit as the Moon goes around it, because they're orbiting around each other. Stars and planets are the same way. So as a large planet goes around a star, it perturbs or moves that star just a little bit. So sometimes, because of the way the planet is moving, the star is coming toward you, Doppler shifted toward you. Sometimes it's coming away from you. The color that the star is emitting when it's coming toward you is shifted a little bit to the blue. When it's going away from you, it's shifted a little bit to the red. And so by looking for those tiny variations, those tiny Doppler shifts in the frequency or the color that's emitted by the star, we actually can infer there must be a planet there, it must have this rotation period, and it must have this mass, and it must have this distance. So we actually can tell that there's a planet there even if we can't see it. Most of the planets we've discovered, up until fairly recently, were discovered through this radial velocity technique. More recently, we've had an instrument up in space called Kepler that stares at the star field and just looks for stars dimming just ever so tiny amounts as a planet moves in front of them, changing their light ever so little, 1 part per million to 50 parts per million. Tiny, tiny changes in the star's brightness. And so over time, we've actually seen that planet, or at least seen it basically shadow the star that it's passing in front of. But then sometimes as it's moving around, we can also see that that planet reflects a little bit of light from the star. And when it disappears behind the star, we see the light dim just a little bit again. That's called a secondary eclipse. By studying the primary and secondary eclipse, we can learn things like how big the planet is, how bright its surface is. These are fascinating little details about a planet that's a long way away that we can see with the instruments we have today.